So a large portion of your grade for this course is going to be the group projects. Now I want to take a little bit of time to discuss the details and expectations for this group project. So this project is going to deal with the design of assistive technologies. So what that means is this design is going to be directly related to rehabilitation science or some type of assistive technology. So this definition will broadly be interpreted to include any device that is going to be helping people perform activities. So that's a pretty general statement and will allow for a lot of different types of projects you guys may have. So this includes devices that aid people with disabilities, help people recover from an injury, or enhance physical or mental capabilities of healthy individuals. So these activities may range from typical things like activities of daily living or for higher function applications such as sports or leisure. So the focus of this should be on mechanical side of these devices and not just on the electronics or programming side of it. So an example of that would be, let's just say you're designing a wheelchair. You're going to take most of the time in this project designing the mechanical components of that wheelchair, doing your factors of safety, material selection, things like that, making sure it's supportive and meets all the criteria on the mechanical side, and not as much time as if it's on the electronic side of it if it were an electric wheelchair. So with all of your projects, they must identify at least one of these three important goals listed below here. The first one being a significantly novel design. So not just reproducing a part or a component from an existing device, but something new and novel. Two, a device similar to an existing device, but you found a way to make it a significantly lower cost. Third word available, or materials or components are changed. And lastly here, the third one, a similar design to an existing device, but it adds some significant improvement. So you may have had a device that had limited capabilities, all of a sudden you found a way to make significant improvements upon it. This could be in the aesthetics, the sustainability profile, safety, or environmental concerns. So here I provided a list of potential examples to kind of get you guys going, brainstorming ideas for your project. So some examples of good projects for this assistive technology would be wheelchairs, hand bikes, bed to floor chair, chair to tub, other type of transfer devices, stair climbers, walkers, prosthetics, some type of vehicle, industrial or farm machinery interfaces, specialty outdoors, athletic or sports devices, or any type of device that aids in activities of daily living, washing, cooking, cleaning, leisure, care of children or elderly. So these are just a few broad examples to get you guys thinking about some projects that might work for you. So this project has been broken down into multiple steps. It'll be due at different dates throughout the semester. The first step here is the formulation of a suitable needs statement. This is where you're going to create that statement and what your design requirements are. So within this, what you're going to do is you're going to write a short needs statement that clearly identifies the objectives and functions of your design. Decide on the design requirements for the application. These generally include statements on performance, reliability, cost, and manufacturability. Also, you're going to identify the target end users for this device. This is all within step one. You're going to be creating a statement to include all of these. Now for step two, this is the retrieval of supporting information. This is where you're going to begin your background research. So you need to find out what you need to know about existing designs that are on the market and what the associated standards are that need to be met. Now this may come from industry standards, government regulations, user criteria. And you need to write down also and explain how you determined what these standards are. You're also going to need to find some information on how your components are manufactured or how you propose to manufacture those components. You can use internet, use your books or the library, or send emails to companies in order to do this background research. So as we move on to step three, this is the translation of the design requirements to your chosen design. So there's a lot of bullets here and we'll go through these one at a time. So the first one being the design must include the overall design of the mechanical system. So again, we're focusing on the mechanical system here. Two, the next bullet here, the goal of your analysis is to justify the choices you have made within your design. This may be the geometry, the materials, the function, and prove that they will meet the design requirements and objectives. Now you should also express your design utilizing CAD drawings, and I would recommend SolidWorks. And if you're taking ME83 along with this class, it'd be a great opportunity to use your project in ME83 for your CAD drawings and design for ME171 group project. Your design must include general analysis of motion and loads on the overall device and the individual components. So with the individual components, the design must include detailed design of failure for at least 3 separate components of the system per student on the team. Now for your analytical solutions, please back these up with SOLIDWORKS FEA whenever necessary for the more complicated loadings and geometries. You're also going to use FMEA to find what components are the most important for you to investigate and do some of this design of failure for. Next, I want you to identify the material properties. So look at the properties and materials you're going to be using for each of these individual components and which ones are important to meet your design requirements. And this will come into play as well with your FEA when you're assigning those material properties to the individual components. Next, I want to show how safe your device is. Use your safety factor calculations. And I'll mention that this design does not have to consider the details of the electronic systems. We're just going to be focusing primarily on the mechanical side for this. This now leads us into step 4, which is the actual write-up. So use the outline that I'm going to show in the following slides. Build your proposal. Include discussions of costs, your standards, manufacturing, and sustainability. Leave time to mesh the writing styles, terminology, and quality in the formatting among various contributors. So this is something that's important. You have these groups that you're working with. You want the whole paper, the whole write-up to flow nicely. So even though each person may be having a different assignment within it, the overall writing style is something that you want to flow very nicely through it to look as if one person wrote it and it's not a jumble of different ideas. So this is something to consider as you're breaking down the tasks for individual group members for this group project, is maybe you have one person who that's going to be their task is the overall writing and flow of this, or somebody else might be doing just the calculations or just the SOLIDWORKS meshing components. So how you divide up the task between the team members is going to be important for this last part here to make sure that this whole report flows nicely. So taking a look at milestones and dates, this is something from the time management side you want to keep track of. I know we're introducing this day 1 of the class, but these due dates will come up quickly. We're breaking this down into individual sections. So for the first section here, on March 2nd, you're going to form your teams and submit a list of the team members. So each team should be roughly 3 to 5 team members. But on March 16th, I'm going to have you guys submit your white paper summarizing your decisions. This is related to step 1 that we just discussed. Then on April 13th, you're going to submit your 5-page outline presenting your work. This relates to steps 2 and 3. And on April 29th, this is your final design report here. This relates to step 4 here. These will all be submitted as assignments through Blackboard. And last big portion of this here is your actual virtual team presentations using Microsoft Teams for your group project. This will be on the last 2 days of class on May 4th and May 6th. So this is the format that we discussed briefly here I want to include. So you have your introduction, statement of needs, how it relates to your design criteria, the design itself and all the individual components that we discussed there for the design, then your conclusion section, future directions, feasibility, and don't forget as well the reference section. So as you're getting started, it's going to be very important to make a plan here, get together as soon as possible, form your groups, define what needs to be done for this project, assign different people to the different aspects that we talked about there for the project. This might be the research, the write-up, the analytical solutions, FEA, all of that. You will peer review your group mates as component of the final grade, so make sure that everybody contributes. So this now leads us to the evaluation criteria for the project here. So equal weight is going to be given to the categories of the technical competence and sophistication and the style clarity of write-up. So what you're going to be graded on here is the group report that you're going to turn into me is going to be 90% of the grade, but then your peer review of your work here is going to be 10% of your grade, again, to make sure that everybody contributes evenly to the group project. Make sure to include your references, proper citations of books, journals, websites. Please avoid plagiarism. Make sure you cite everything you do and include a good reference and citations within your report. So take a look at the UVM library section here for some help on formatting for that. So as a little summary for this final project here, I know it's a lot of information in detail. The intention for this project was to break it into 5 different parts here that we discussed there, and that's to help everyone stay on track and set milestones for the completion of the project throughout the semester. Those due dates are going to come up quickly, and this will help hopefully keep you on track and getting everything accomplished up until the final report and presentation of the project. And this is just to really help you guys avoid waiting to the very last minute to complete the project and being overwhelmed at the end of the semester when you've got other exams and other projects due. So please start early, form your groups early, and stay on top of things throughout the semester. It's going to help you out towards the end. So again, here's these milestones I listed before, now on a separate piece of paper here, so you can reference back and see when these are due. These are all posted on Blackboard as well. So what I have here is just a 1-page summary for clarification for all the different steps along the way for your final project. Again, the first thing you want to do, create your group. Within that group, come up with a project idea. From that project idea, create your 5-page outline. And from there, complete your final report from that 5-page outline and get ready for your presentation. So this is just a quick overview of what we talked about in all the previous slides here for all the details of your final project. So this leads us into the grading of it. So this is something I want you to look at before you even start your write-up to understand what you need within that final write-up for your presentation. So we have here your introduction section. This is going to be worth 5 points. Your statement of needs and how the designs meet the criteria. This is worth 5 points here. And I took a section back out of the description from the group project statement. Next, we get into the design. This is where a bulk of the points are. You get 10 points for your design overview, 10 points for your performance and reliability and safety requirements, 10 points for your component overview, material selection, 50 points for your individual detailed component analysis. So this is important. Make sure you have those each individually done. This is the bulk of the grade. Cost requirements, 5 points. Industry standards and government regulations, another 5 points. Manufacturing requirements, 5 points. Sustainability requirements, 5 points. Conclusion, future directions and feasibility is 5 points, and your references are 5 points. Then it has a little bonus 5 points there if you want a little above and beyond, did some extra stuff in there. There's an extra 5 points awarded there. And this is so total of this project is going to be out of 120 points. So this is your rubric. This is how this is going to be graded. This is what the TA is going to be used to grade your assignments. So this has everything you need. So as you're writing this up, make sure you have a section for each of these parts for your write-up. So that's where we came up with this that I showed earlier. This write-up format right there is directly from that grading rubric. So make sure you follow this. And again, just 1 page right here so you can quickly reference back and pull this up as you're starting to write up your final projects.